Hi, I'm Dr. J, and this is a video about comparing more than two normal means. So in a previous video, hopefully linked up here, we talked about situations where we had this same model, but where there's only two groups, so that capital G was 2. And in that situation, right, we talked about having samples that are independent from each grouping having its own mean and its own standard deviation. Okay, so this is just notation to make that happen. And we talked about ways that you could go about using statistics to inform you about the parameters of that distribution and importantly about the means of those distributions. So typically what we're interested in here are the different mu g. And right, so just like we had in a previous video about binomial proportions, we can first perhaps start with a test of equality of all those means. If we want to go further, we can start doing comparisons of individual means, either by p-values or confidence intervals. If we want to take a Bayesian approach, we can get posterior distributions for all of those parameters. We can look at credible intervals for differences. We can calculate posterior model probabilities. We can look at comparisons of two of those means at a time to see what the probability is, what our belief should be about one being larger than the other. All right, so we're just going to extend the process we used in the previous video where we have a production facility. There's multiple processes that create these sensors. We measure the sensitivity of those sensors, and we have some kind of data that looks like this, right? So we have a sample size, a sample average, and a sample standard deviation for each of the three groups. All right, so we can start, say, by conducting a hypothesis test that all the means are equal. Here we have a very small p-value. This indicates the data seem incompatible with that model, which again just means that possibly it's the means that are not the same, but it could also be independence assumptions, normality assumptions, constant variance within groups assumptions, and so forth. So we would need to go and investigate this more. As part of that investigation, we might look to see whether individual pairwise comparisons of different means indicate that those means are the same or not. In R, there's a pairwise.t.test that you can use. You'll see here that I've had to do a number of adjustments to sort of get it, change the arguments to get the results that I want. But those arguments could be changed for different purposes. In particular, the p.adjust.method, I just made it none because we haven't talked about multiple comparison adjustments, but probably something we want to do in this scenario. In the next video, we're actually going to talk about what happens if you pool SD, right? That is if you assume that the variance is the same across all groups. Okay, so this gets us to look at some of the ways that we can look at comparing different means across different groups. If we take a Bayesian approach, then we have a model. We need a I guess I didn't even say what it is here. We have a prior that we need across all groups. Like in that true group example, the prior is just going to be the product of the individual priors, which were all 1 over the variance for each group. Right? If we use that prior in this model, then we have a posterior, just like the previous video that has a t-distribution, right, with the same parameters that we had before, but now we've just added a new group. Using that posterior, we can draw samples. When we draw those samples, we can, say, construct histograms. So here is histograms of those posterior means for each of the different groups. And the group that we've added compared to the last video is this P3 group. And so the lower density and the wider spread on that density is really because there were fewer observations from that group. And that's why we don't have as much certainty about what that parameter is. Now, what is important here via the simulations that we're taking, because again, these densities were actually available in closed form, so we did not need to take simulations, but we're going to use those simulations to calculate posterior probabilities of certain means being greater than other means. And so there's a bunch of code. I'm not going to go through all that code, just want you to focus on the bottom. On the bottom there, we calculated two quantities. One is that we calculate what's the probability that one parameter is greater than the other. And the second thing is we calculated a credible interval for the difference between those two parameters. All right, so in the next video, we're going to talk about what happens when you have a common variance in these normal models. Hope to catch you there.